BSides DC would like to thank all of our sponsors, and a special thank you to all of our speakers, volunteers, and organizers for making 2018 a success.
So the topic today was about DevOps and security in DevOps, and my name is Tej Luthra, and before we kind of start, I wanted to provide a little bit of a disclaimer from our legal. There's a little bit of feedback.
You have to speak up.
Okay.
Yeah.
All right. So I just came out from a really bad cold, and I'm still kind of running through it. So I'm going to try not to yell or be too loud, otherwise that's going to be the end of me. But anyhow, this is just to kind of talk about that there are some of the things that we are doing in our development shop, and there are some forward-looking statements also, and we're also talking about there's not much confidential information in this deck. As such, it's all private, and wherever the sources are, I've actually labeled where the sources for those information and documentation is. But if there is any future or any forward-looking statement, I'll probably point it out. But just to kind of keep that in perspective. So my name is Tej. I work in Merlin, and Merlin International is a good 21-plus-year-old company. And prior to that, they had a different part of the business. So in 8 years, they did a lot of web development. And over the years, Merlin has had different, I'd say they wore different hats. We built a lot of software for many major companies, and that business sort of got divested about maybe 10 some years ago, and then it moved into more of a reseller and solutioning business. But overall, for the last 21 plus years, it's been predominantly cybersecurity. So, and our market has been federal as well. So many of the agencies we've had we're working with, we've had some really good relations with them over 15, 16 years and running. And we are also moving a lot more into the commercial space. And last year we changed a little bit of direction. It wasn't massive shift again, but we retained our reseller and the distributor business that we have, but then we also took on product development. And this was again after probably a lapse of a few years, we went back into product development. And the main reason was to provide IP. Our own IP, because we felt we could solve a lot of these problems that we come across in a day-to-day basis in a very different form and start to differentiate in the market. So not being as a reseller anymore, but now this becomes much more bigger when we go to our customers, where we're not only stitching them a solution that's important to them to solve their problems or align with the mission, but we're also looking at ways to kind of solve security problems with our own product as well. Joined with me here is Devesh Arora over here, and he runs the engineering part, and we have since it's a young shop, we kind of broke a lot of norm in terms of how we wanted to set up the shop, and it's very young too. Like many of our developers, they are roughly, I'd say 6-7 months old is when we started stacking up the shop, and then we have a team of about maybe 25 people now, so we really grew very quickly. So he leads the microservices and web development area of our engineering division. So today we're going to talk a little bit about DevOps. We're going to lay the foundation and then talk a little bit about what security means in DevOps, and kind of translate that into some of the requirements that we see come in. What are the challenges? Set of guidance that might be relevant to many of you, or if you come across situations, maybe these guidance can actually play a huge role. But fundamentally, what I really wanted to do was kind of open up as a broader discussion and kind of give you examples as much as possible, and also talk about some of the practical experiences that we've had over the years. My past experience came from Netflix, where we really ventured into DevOps, so we really built it out from the ground up. And then I went to IBM. It was total flip, completely different, but then we could see how we could apply the same DevOps principles to this massive company and try and bring the same efficiencies that we wanted to bring. So I've had that kind of a past experience. I want to bring some of that back to you guys, and then kind of talk in broad sense, also go a little bit technical where I can, but also leave at a policy level up front, so you guys can actually see from a broader sense where it makes sense, and kind of give you some anecdotal examples as well. So I wanted to start with this slide, and it's kind of good to understand where the market is going and what industries and companies are really looking into. And if you're in a certain industry, it's always good to keep track of what your industry is moving towards and what they're trying to achieve. So what this chart actually shows is predominantly for adoption of security in DevOps. And this was published by Gartner, I think, in earlier this year. I can't remember, maybe it's 2018 or late 2017 report. But it's pretty evident that there is a shift of bringing security into DevOps. And with that, there are tons of opportunities and benefits. And I wanted to start with talking about, laying the foundation. Let's say we know and understand what DevOps really is, and we implemented some level of that framework in our organization. The opportunity that security in DevOps presents is about continuous assurance and providing continuous information assurance to the way we deliver software. And this has been pretty much, it's been more and more evident with cloud native technologies, with adoption of cloud, by moving into infrastructure as a code. If you look at these different paradigms that we've started to adopt within the organization, you start to see that that's actually been feeding into this requirement of information assurance, and that's where the big opportunity really lies in DevOps. So fundamentally, if you kind of look at the adoption rate, within a year or two, what Gartner kind of talks about on the top little bullet over there, from mere 15% to they see about 80% adoption and incorporating of these capabilities within the existing DevOps pipeline. And there are tons of challenges too. It's not that it's here's a tool, just implement it and here it goes. There's a massive undertaking and understanding of why we need to incorporate these physical aspects into or the processes that we do, or the tools that we utilize. Even the mindset of the people who are implementing DevOps, that becomes a big factor as well. But if you guys are looking into building a startup, I think this is a great area to kind of focus into, because the market is fresh. There's not too many standards out there, and there's a lot of requirements coming in, but the growth is phenomenal. That's pretty much what it is, and it kind of boils down to. So along the course of this presentation, I'm going to talk a little bit about the components of DevOps as well. And you've already used some of this, or maybe you know it, but soon you will realize that it's not actually a tool. It's really a practice. It's a methodology that we want to implement, and we want to leverage the best of what it provides. So you'll see things like continuous integration, continuous delivery, continuous deployment. Those kind of artifacts become really important in a DevOps environment, and those are again the key components of how a DevOps organization succeeds in a way to be able to provide what they need to provide to their customers. And we'll talk a little bit more about that as well. Benefits are huge. Predominantly it's about staying closer to your customers, being able to deliver your software to your customer in a short period of time. And it's all about being competitive and have that competitive edge. So the whole idea of DevOps is not just about, here's a new process and take it over and that's about it. It's really about providing that content to your customers and being closer to them, and being able to deliver these features in smaller components rather than these large monolithic applications or large features that we are traditionally, used to kind of delivering. It kind of breaks that norm down into smaller chunks, smaller manageable chunks, and then provide that as a feature set back to your customer base. So it's really about, going back, and then, the benefits of bringing security inside this are phenomenal. Because as we're getting into this new mode of continuous delivery and being able to, shorten the time of providing this content back to your customer base or into your production application, it also brings a lot of risks, because you're kind of running at a very fast mode. You do not want to overlook a lot of these components about security, about code quality, about just common sense that you would normally use in any code development process. So there are lots of benefits of bringing security back into DevOps, because it can reduce your risk, it can reduce your cost quite a bit. And as we all know, that if there is a bug fix that needs to happen in production, it's probably 10 times or 20 times more expensive than actually fixing the bug in much earlier in the cycle, in the development cycle. So kind of wanted to start with that there is phenomenal opportunity that we see. So let's spend a little bit of time about what DevOps. I kind of talked a little bit about this. I don't know how much of Agile do you know, but DevOps to me is, Agile on steroids. I mean, this is how I see this. I mean, Agile kind of took this huge paradigm of waterfall and took, these massive projects, and then waterfall was literally about, following step A, step B, step C. But then it took a very long time. So Agile, what it does is it starts a formation of smaller teams, more collaborative, more functional teams in a way. So we talk about a lot of full stack teams coming together, providing a feature delivery. So the mindset kind of changes from a project delivery to a product delivery. That's really what Agile really did. And when you get into a product delivery mode, what you start to see is that you're more in tune with features that are going out to the customer. You're kind of less worried about infrastructure. You're kind of less worried about the mechanics of how things are actually functional. I mean, it's important, but you start to deliver based off of a business requirement that's out there. So if certain feature requires, if there's a requirement going into the business function, then you would spend time on it. Otherwise, you put it on a backlog. So what DevOps allows you to do is implement a methodology to deliver software using Agile methodology. So, and really the focus here is to accelerate the product delivery for customers. I mean, that's the basic goal of it. And there are many other, components of why you would want to do that. And there are some conversations about, I'm sorry, I'm trying to figure out where the mouse goes. Yeah. So the core components of DevOps that we talk about, it brings a lot of continuous components to it, which is continuous integration, which is a principle of implementing code changes or deploying code in a pipeline. And a pipeline is radically different from, siloed applications, because pipeline become part of a functional operation, and they all kind of deliver an end product at the end of completion. So continuous integration provides the code into that pipeline. What continuous delivery and deployment is about, taking that piece of code and cycling it through different phases of code promotion and deployment, and getting into the state where it needs to be. And what you also see is a lot of components around continuous testing, about continuous quality, governance. All these become part of the, how a DevOps organization really is formed. And those are the core tenets of any DevOps component. The question becomes, why DevOps? Why do we need it? And it's fundamentally really, the basic requirement of DevOps, why it came around, was the business need to accelerate product development and the way they can accelerate delivery. And it was really a business function for it. So the focus of DevOps has been how to move new features to the customers as soon as possible. But then with that, there's a radical change of culture that we talk about. And the change is really on providing the developers the keys to the kingdom, because now they are much more closer to your customer, because they are not only developing the code, but they are now responsible for deploying the code into production and also managing it. And that's where operations and DevOps comes into play, because your development team is also now your operations team. So you kind of take that whole paradigm and you squeeze it into one. You give them the freedom, you give them the responsibility, but then they have the ownership of fixing things if they were to go wrong. So there's a lot of ownership that comes into the team on delivering that piece of component. And the basic functionality or the basic requirement for DevOps is that it tears down the traditional silos of IT, especially around development and operations. Excuse me. You do? I just emptied my my Ricola. I was thinking of calling in sick today. I had a perfect reason to do that. All right, let's see how it goes. I'm going to talk less and skip. some of the advantages that we've seen across the board from Puppet Labs, from Bank of America, and others is really about delivery and reduction in the bugs that they've actually seen by implementing this process. So it's beneficial. I mean, when you go across seeing what companies have done and what they've achieved, there is phenomenal growth, but the journey, to that point is really, it's something that everyone has to undergo. Like, you can't just plug in DevOps and say, I'm DevOps and we are good to go. It's really a journey, and it's not a destination. That's how I kind of see this. But once you kind of incorporate that journey in your process, there is huge increments. I mean, Guilt, for example, had this, for about Guilt is an online shopping app, basically. I mean, you can go in and you can choose your, what kind of clothing you want and stuff like that. They implemented DevOps and they used a microservices-based application delivery methodology, and for about 2 years it was really about building the core components, building the platform, getting things set up. So the number of features that they delivered was probably relatively okay. I mean, not too many, but once the platform was kind of set up, they had an exponential growth of delivery of each feature set. So that's what happens when DevOps goes right, because you get phenomenal growth in terms of delivery, in terms of providing more features to the customer without adding the cost of additional development to your organization. So there are phenomenal advantages of implementing your application using a DevOps process or methodology. And it's also something you have to kind of realize whether how your current development processes are, how do you support your current applications. It's really easy to do this in a greenfield way. If you have nothing, you're starting from scratch, this is perfect, this is great. But if you already have a process and you have to maintain old applications, or you have to refactor something, then those are kind of things that you probably have to think about, why you would like to implement, or why would you even want to embrace DevOps in a way. So just like any other process or tool or a method, there's always pros and cons, and here are some of the challenges. When we get into this DevOps kind of mode, getting an understanding of what kind of auditing is required, what standardization is required, how much reporting do you have to do, how much oversight you have to do, all those things, implementation of controls, constantly changing assets in the delivery of those components or the features is really important. And I'll talk a little bit more about these changing assets, because you're moving into a cloud-based methodology. You're virtualizing everything, you're spinning up servers on and off. So it becomes really difficult to kind of understand, what is changing, what's not changing, where are your configurations stored, because you don't have a physical asset anymore. You're kind of moving everything into code. And with that becomes another challenge on segregation of duties. Like, how do you, provide compliance when your development is the guy who's building but is also making bug fixes in production and things like that, or your operation team is so much more closer to your development team. So you want to be able to understand the segregation of duties. The other thing is around, this virtual asset that we talked about, what kind of authentication schemes do they leverage? What do they use? What kind of cloud provider are you using? Are you building everything yourself, or are you, leveraging some capability provided by someone? So you have to kind of decide and understand what do they give you, and how do you adapt your requirements to, or your processes and your standards to what they are providing. So it becomes a little bit of a challenge kind of starting out with. So because you're kind of relinquishing control as well. You're kind of giving away your control when you move to a public cloud. So you have to sort of come to an understanding of whether it really aligns with what your ultimate goal is. But there are opportunities because you're constantly improving. There's a lot of automation you kind of bring in. You break down these, siloed processes of, not only code development, but all the way to the end. So when this happens, when this kind of automation and you're kind of crossing across between teams, you start to see a lot more collaboration. In many companies that I've been, you start to see a lot of buzz and lots of small team huddles, because there are constantly people from different parts of the business, and they could be the line of business, they could be the security team, they could be the DevOps team, or the developers and the architects. They're all kind of coming together. And this is a very healthy thing that happens, because traditionally, if you see in a waterfall model, you are typically designing something, throwing over the fence, the next person takes on something, produces an artifact, throws it over the fence to somebody else. And then so on and so forth goes. I mean, there's very little interaction that's happening. So those are some of the opportunities where teams start to come together. They understand, there's much more communication, and it also avoids these last-minute manual audits that we kind of look into. Because you're continuously developing and implementing standards as you're building the process or as you're building the application. So there's much more oversight into how you are actually deploying quality. And if there are some audit requirements that are coming in, those become continuously deployed. And we talk a little bit about threat and vulnerability management as well. So this is where lots of opportunities do exist. The whole paradigm of DevOps is really about shifting left, and security is no different. You start taking all your processes, whether you are designing, or you are probably doing security checks, or you are getting together with your business, you start to bring them early on into the development phase. You start to shift left a little bit, and so that's another big change that starts to happen quite a bit. But then it also provides you standardized configurations. For example, things and frameworks that you have, like code frameworks that you might have to use. Across the board, you start to see everybody kind of leveraging the same kind of framework. So if you're containerizing all your applications, everybody decides on what kind of container applications you would be using. Or if you're using a certain framework for Java, then everybody kind of comes in consensus that yes, this is the right way to kind of go. So you start to see a lot of these things happen early on, and it makes the teams actually much more productive in a way. So I really wanted to quickly touch on this end-to-end product lifecycle, because the rest of the deck kind of talks a little bit about these different components and how security kind of plays a role. But I've kind of broken this down into 3 different sections: the development, integration, and then you have production. And we talked about DevOps. It was really about development coming together with production and kind of breaking the silos a little bit. But there has to be a handshake between them. It just doesn't happen overnight that, I built something, I built an artifact, and then it's gone. And then it's the operations guys' turn, or when it goes into production, that's when I'm going to start looking into it. So to be able to provide, quality code, it has to sort of follow some sort of a sensible process. But many of the toolings that are available today, like the CI/CD processes given by Jenkins, for example, or others, they all do incorporate many of these components within. So the tools are kind of getting mature in the way to provide this kind of automation. But if you kind of start from left to right, we look at the development portion kind of starting first, where developers get together and they produce some sort of an artifact. And it's typically is a form of a code, maybe a Java file or a class or something, or maybe a package that's available. And that package is then tested. It could be the developer who's testing, maybe it's a unit test or functional test, but then it could also be a dedicated testing team who's actually applying a lot of tests to it. And that's where security scans could also happen. Once that is done, it's validated for certain KPIs that you were trying to measure for those particular tests. So that's when the business validation component comes into play. And then once a component is produced, then the security checks need to happen at the same time, because what you're trying to do is not wait for the application to go to production to do the tests or the checks, but you want to do them early on. So you provide guidance in terms of what kind of tests, what kind of checks you want to do, whether it's checking for hard codes or bad vulnerabilities in the code, or cross-site scripting, or any kind of other tests that you would want to get done. You would want to do them early on in the development phase, and that's where all this kind of sticks. So once that is done, what you have is a secure package that is ready to be shipped or deployed. And the integration component really talks about, how do I take components that I've built during my build phase and transfer it to the next phase, which is either it could be a staging environment, or it could be a load test environment, or I'm ready to kind of take it to a certain level and it's almost production ready, right? So I want to be able to get to that point. So that's where you see the integration come into play, where you have those packages and you start building platform-specific delivery artifacts. And platform-specific is, as we're kind of, getting into this multi-cloud environment, you want to be able to create your code once and deploy it into any kind of cloud environment if you want to. And that's where it becomes really important for the platform to be agnostic to what kind of cloud you will be deploying your application into, or it should be aligned with what is your target environment. So if you are using containers, makes it so much easier, because you build a container and you basically ship it off to wherever the container orchestration engine might be, whether it's at Linux, or if it's a Kubernetes based or wherever it is. Newer technologies kind of make it easier, But then if you're looking at other applications which are kind of running as virtualized in VMware or KVMs, so you have to kind of think about how you're going to deploy it, but the platform becomes really important for that. Now when the platform is created, when you have the images that are created, the journey doesn't end there, because you have to constantly go and check and make sure that those images or the packages that you've created, they are still clean and there are no vulnerabilities in this. So constantly scanning them for CVEs or known vulnerabilities or patches that need to be applied. Let's say you have a version of Java running in there which is known to be vulnerable. So you need to be able to go and scan those images constantly over time to be able to find when they are susceptible or vulnerable before somebody comes and exploits them. So you want to be able to do all that in the integration environment, and those applications, validated ones, are the ones that run in production. So you can see that the ownership is really on the left-hand side and not really on, the production should still be very light, it should be running as designed, because that's where your user experience really is. Your user should not be the one suffering because you were trying to deliver features faster. It's really our own ownership on the left-hand side to be able to produce quality product, and so that this kind of explains quite a bit about the whole journey that is typically in any kind of an agile shop and in a continuous delivery environment as well. So going into a little bit of these different components we have, CI, CD, so we'll touch on a few of them. And this is something that we've implemented in our environment as well. But it's kind of, just kind of giving you a very high level view. In the continuous integration, you're really at the build phase, where you're trying to build code. And you kind of see the whole process around the code commit, which is really where the developer comes in and you're kind of committing the code. It goes through quality scans. It goes through a build and unit test. And then, you want to sort of package it somehow, whether it's a container or somehow, whether it's a jar file. And once that package is created, it's ready for the next step. So you basically have a compiled code at the end of CI, at this frame. That's really what it is. But what it allows you to do is frequent code check-ins. You can check into a master. You don't have to have multiple branches. So it kind of keeps your code base very lean. But it also brings a little bit of complexity if you have to do that. But these are things that your team can actually sit down and identify and feel whether this is the right process for us. How do we make pull requests? How do we deploy into a branch? How many branches we should keep? Because now you're looking into multiple teams providing multiple features, and they're all running in parallel. So if you have too many branches, after 1 year, you might have a really hard time understanding how many branches you have and how many of these features are kind of going. You kind of break away from the norm of keeping things nimble, and you start to complicate things. So those are some of the decisions one would have to make in the CI phase itself on how one has to manage the code and deploy them. So this is where some of these processes become really important. Now the delivery phase is really when you've created a package, which is really a piece of compiled code. It could be an image, it could be some artifact that you have, and you put it into a central repository. And this repository kind of not advertises, but this is a place where everybody kind of subscribes to pull the final piece of information that they need for deployment. So if you have built a UI component, the image for the UI component would be in this artifact tree or this artifact repository. And from here, you would the continuous delivery process, whether it's built on Jenkins or Bamboo or whoever that is, whatever that program might be, they will pick it up from there and deploy it into a target environment, which is your test or the staging environment. It doesn't go into production because you're not doing continuous deployment, right? Your continuous deployment, you kind of break the norm and you're touching production right away. In this case, you're only going up to staging, but you're doing full functional integration, security checks up to that point before releasing the code into production. So that becomes a big part of how you manage code and how you start to deliver code within your organization. And the next one is about continuous deployment. You see, it's kind of more or less the same, but what you're trying to do is now you're breaking the barrier and you're going directly into your final production environment. And this is where you have either you've enabled live updates in your tool chain, or you're considering building a deployment plan that goes directly into your production server. So some companies do that. Many apps that you actually use today on your phone, they typically do work on this philosophy. But the whole idea is that we've tested the code enough that it's now ready to go into production, and it's faster delivery in a way. But the whole idea is that the code promotion actually happens all the way to production at that point. So let's talk a little bit about security in DevOps and why would that be really important. First of all, security is everyone's business, and we as application developers, as applications users, we all have the responsibility of making sure that the enterprise is secure. Typically we talk about secure DevOps from an application development standpoint, but then the question becomes like, what if an organization does not build an application? What if they don't have any development shops? Does it still apply to them? Fundamentally, the process of security applies to everyone. It's just that everyone has to define the process and procedures and flows and workflows, because what they define will be applicable to how the applications are consumed in their organization. So it's important, because at the end of the day, we have hackers and criminals who are literally coming in to find these vulnerabilities in your application and basically try and breach in and then exploit, and then once they are in, they try to go laterally elsewhere to find critical assets and essentially basically take control. So having security not only in the DevOps but overall as an application sense in the organization is fundamentally very, very important. And it should be part of a security strategy that you have. And the security strategy is driven by many, many different reasons. It could be because of compliance, it could be because of regulation, it could be because of the industry you're in, or the kind of application that you're building. They all mandate certain requirements around security. So before getting into any kind of development, whether it's for an application or if it is for delivery or whatever it is, it's very important to spend time before the first piece of code is written, before the first dollar is even spent, to define what the security strategy is going to be. And when we apply security in DevOps, these strategies need to be transferred back to the PMO office, who is going to be putting together the plans for development. Because that communication needs to be transferred and shifted left in the right form and in the right expectation. Otherwise, they will never get done. If we say that we will build the policies and we'll do something afterwards, we just need to deliver software to the customer and let's just get going with our application development, that would be probably a recipe for really a lot of pain at the end. So you want to be able to provide what the processes and protocols are up front, kind of give it to the relevant teams up front. So some of the challenges people say is that here we are trying to run at the speed of light, and now we have these processes that we have to take care of, and it all goes down to cost. The cost of fixing a bug, cost of a breach, cost of defame a brand situation where a company has been breached. Those costs outweigh any of these other things. So as an organization, one has to weigh the risks, and it all comes down to how much risk am I ready to take and how much risk am I willing to forego. So it's not that it's not binary anymore. So the security teams, since they are working much closer with the development teams, they have policies and procedures provided to them, but they are also constantly evaluating the risk. And if it turns out that there are certain features that are going into production that do not form or conform to the policies, then it's important for them to convey the risk back to the business owners, because then a proper decision can be made to let the feature go with a known set of risks, or maybe with a known set of roadmap that yes, this will be fixed in a certain amount of time. What is the validity around it? A lot of times the challenges come out that the teams say, hey, listen, we're behind the firewall. We're in a private cloud, so we probably don't need all this stuff, which is probably a really wrong thing to think about, because all the hackers or what they need is really one vulnerability, and once they are in, it doesn't matter whether it's a private or public cloud. I mean, there's a lot of conversation about blockchain, and here we have peer-to-peer validated network, and if it's a private blockchain, then it's really, really close. But security is security. I mean, and once you're breached, it's the same security principles, they will apply. So I even talked about the considerations, but that's really the understanding what the methodology we are leveraging, what kind of physical infrastructure are we using, so on and so forth, what kind of testing methodology is being used. I mean, all those things kind of weigh into understanding what's the route of security in DevOps. So let's talk a little bit about the life cycle. I mean, we talked, this in the larger sense, but if you look at the chart, this is where, all the development is happening and the developers are checking in code into the build process. So during all these steps where we are providing, code as a delivery pipeline, right? We're providing features in a pipeline rather than a silo. This is all a pipeline, and we are soliciting feedback directly from the customers. So if things break, we're getting an understanding of why it's breaking. People can actually, hop on a chat, and they are literally connected to the developer who wrote that application nowadays. So there's this constant feedback loop that's coming in. So in this kind of paradigm, where we're connected to the customer or to the end application, and you have, very few kind of, hops in between from the developer to the consumer, the life cycle becomes really complicated because you want to be able to provide all those capabilities up front. So common things that you can do up front is, provide static dynamic testing, for example, or vulnerability testing, which is, if a code smells, or if a code is, not written correctly, like you left API keys in there or something. I mean, those are kind of things that, we got to be able to scan. We also need to be able to scan the images as such, the baseline, the operating system, what kind of, ports are open on those baseline images, and what are we using to kind of secure them, because if we go through a stake process, it's very, very evident what they really want the systems to be and how they want to operate on those systems. So all these security policies and requirements, they need to be provided early on, and the feedback going back to the CISO or to the security application security team is in the form of reports, because they need to understand how these tests are coming out. So if somebody's running a pen test on the development systems or on the image, the outcome of those pen tests are really important to see, because it tells how those vulnerabilities can be exploited, what methodology was used. Because at the end of the day, the pen testers are really thinking like hackers. They want to exploit the system just like any hacker would do, and they formulate a process saying, hey, this is how I'm going to come into your system, and these are the steps I'm going to follow to come into your system and do a certain breach or attempt to do a breach. So getting an understanding of the kill chain and understanding the process that the hackers use, that's really what comes out from all these different tests. So getting all this information back to the security teams is really important. So these are some of the common requirements that come about. Again, it goes back to design. There are three major components to this. We look at the architecture, we look at continuous monitoring, and then the documentation at the end. And on the right-hand side, you see some of the key aspects of what the common requirements are, whether somebody's trying to log into the system, how do you do log management, what kind of configuration management do you do, what kind of physical and personal security, data security are there, data retention, and also disposition of the data is also really important, because in the cloud form you kind of use a polyglot persistent environment where data is kind of stored in different kind of stores, and they're really built for purpose. So you can have a time series graph, you can have an object store, you can have so many other things. So having a consistent policy across the board is really important. It all goes back to what kind of architecture you put together, and architecture is really around your compliance requirements. What services are being used, are the sources trusted, where you're getting the data from, for example. Are we leveraging cloud native applications? All those kind of decisions need to be made during the architecture phase. And then the continuous monitoring is really about governance, about what kind of tools we leverage, what information do we get from them, what processes are being used, so on and so forth. And even the artifacts and the SLAs that are being defined, they're all part of the second pillar. And the last one is about documentation. So, you have a security plan, you execute it, and then you want to see the outcome, and you want to be able to log those. And they eventually become a backlog, because if you're using an agile process, all these pieces of information, they get a score and they become a backlog because they have to be resolved during the life cycle of the product development. So there are some guidance. I don't know how much time I have, but I might have to skip through some of the guidance, but you'll have them all in the deck. These are sets of guidance, they are kind of broken down predominantly into how security objectives are adopted. How do you integrate security across the tool chain, for example? How do you bring your code in? How do you automate the process? How do you deploy it? How do you test it? How do you go back and redo the entire life cycle again and again? So In the next few sections, I'm going to try to cover most of these, but I'll try to run through them. The first important thing about implementing security in the organization is about understanding what the known vulnerabilities are, right? So not go hunt for something that's an unknown, because it could probably be a wild goose chase at times, but knowing a known vulnerability and knowing a way to kind of address it is really important. So in today's development paradigm also, we started leveraging a lot more frameworks, and these are standardized frameworks, so your actual custom code that's written has dropped drastically to about maybe 10-15% depending on what kind of application you're building. But predominantly, since you're using a framework, it's easy to kind of go scan those frameworks for known vulnerabilities. And so it's kind of tricky because some of these frameworks also come from open source, so knowing what the open source component is and what kind of vulnerabilities exist, I mean, that's an important decision that you'll probably have to make. But setting up a process along the way to address many of these known vulnerabilities is always a good way to kind of start. Using this, majority times we can address all the major flaws that are probably in the application up front. The next important component is about hardware and software. Now this becomes really important because what we are delivering back to the customer is infrastructure as a code and software as a service, right? So you've kind of taken away or abstracted a lot of the fundamental physical aspects of application development. So you're going directly into a more coded way of deploying infrastructure. So where is that stored? It's all in configurations. So it's important to understand what those configurations are, because what's going to happen at the end is if you have a cloud provider, they will be spinning up machines and giving to you without any tracking possible. So you can't really understand whether, let's say there's a problem that occurred on system A, the remediation is destroy the system, let's move on. Let's deploy the code to a new system, let's bring it up and running, and we just basically destroy the old system. In a cloud environment, when we're trying to scale, we do the same thing. We want from one web server to maybe 1,000 web servers, we quickly scale up and down. So we get all these virtual ephemeral machines which have no traceability at the end. We kind of lose them as soon as we lose the machine. So knowing all those configurations up front, understanding the baseline OS images that are being leveraged to deploy on those machines is really important, because you're supplying all the security constructs to that image using code, using configurations, using manifests. So all those things are really important to understand in the toolchain itself, in the CI/CD toolchain that we talk about. So all those aspects are actually included. Now, if you kind of go through CIS website, they actually do provide a lot of benchmarks, a lot of processes. So that's a really good place to kind of go look for these resources. And many of the tool chains that exist today, for example, Chef, Ansible, Jenkins and Salt and Puppet, they've simplified the process of rolling this out. So you will probably see a lot more capability in these tools. So you probably don't have to write everything from scratch. So next kind of comes about, if you have orchestrated this continuous delivery methodology using configurations and infrastructure as a code, then how do you go and make sure that these are being deployed properly? So there are certain testing methodologies that are out there, one is called the blue-green deployment. You might have also heard about A/B testing, but blue-green is really about you have your existing system that's running, and then you stand up a new infrastructure, and so you have a green infrastructure that's a new one, so you start to direct a little bit of load into the new one, and you keep the old one running as well, and you test it out and make sure everything is fine, and then you do a final cutover. So in that situation, you are basically providing new feature sets with literally no downtime. So there is no, the application doesn't even know that it's basically being cut over to this new system, because everything is now running in parallel, and then you sort of gracefully switch over to this new system. It's also great for open to early adopter scenarios, for example, where you have maybe tons of agencies or departments, and each department has their own requirements around certain features that you want to release. So instead of doing a company-wide release, you could actually compartmentalize a release only focused for that particular department or agency or for that mission. So you can gracefully roll out to all the other divisions as well. So this methodology becomes much more kind of useful in that respect as well. The continuous vulnerability assessment and remediation, this again is really important because so many CVEs actually get released off and on every time, and you want to make sure that is the CVE applicable to what we are doing? Is the CPE applicable to me? Is there a risk control that is getting impacted because of the CVE? What kind of container? So if you're following regulated industries, it all boils down to what kind of regulation is being impacted by that particular vulnerability, and is that vulnerability in your system? So having this automation framework constantly scan the images based off of those vulnerabilities and how it impacts your organization, and providing your risk assessment, a business identifiable risk assessment, is really important. So that's again where A/B testing and blue-green kind of become really helpful. And all these scans, the more you can shift to the left during the development process, it makes it much more easier, because you don't have to kind of deal with this as an after the fact, because AppSec typically is a different organization and development is a very different organization. So they don't necessarily talk to each other. But with this, if you embrace DevOps in your organization, it's very important for these two teams to start coming together and even have a champion, deployed from security into development, so they can actually, provide those that guidance early on into the development cycle. Application software security is again really something that is important, and most of these tools they are able to provide. I'll talk a little bit about this tooling as well, but they can provide security assessments and multiple code checks that you can do, and you can run through these apps fairly on a constant basis. It's just a matter of how much noise are you willing to take, because every scan you do through an application is going to result into an action that some developer has to kind of go and answer or remediate. So you want to make sure that there's a good balance between what kind of scans you do to how much information is really relevant and are most important to kind of fix, And typically in a DevOps environment, you're delivering smaller pieces of code. There's often a notion of maybe quality can be kind of reduced a little bit, but that really goes back to the development team and the principles that the development team kind of follows on still providing quality code. So it's not saying that you have to relax your coding standards, but it's about being more cognizant that you would be tracking and capturing these errors up front, and there should be a way to kind of handle those up front as well. So the charts actually kind of show you like if somebody leaves an access key in their code base, the scanners will actually go and pick that up pretty quickly. So this is really important, and what happens in infrastructure as a code, in the fundamental nature of DevOps, is that you're probably handing the keys or the keys of the kingdom to one person or a process. For example, infrastructure as a code, the process that's deploying the server is the admin also. It has a lot of privileges to actually do stuff. If you look at the DevOps paradigm for a developer, that developer is fixing code in production, so that person actually has the ability to go and fix something in production as well. And we all know from regulation that it becomes really hard to kind of manage that if the same person is kind of doing the both things. So controlling those credentials becomes really important. So figuring out how to manage that, how to secure it, is really important. So many of these newer tools that have come in, they do leverage keys and certificates, and there is a process of generating the certs and then rotating the keys and delivering the keys as and when the requirement is there. So having those processes inbuilt into your development process makes it much more easier to develop infrastructure as a code and be able to implement all these automation components that you want to do. Because if you don't do that, then essentially you are publishing your username and password out in the open, or there is some methodology that is probably not validated, and it's probably going to leave a lot of vulnerabilities into how any hacker could probably come in and start using your system. Things like HashiCorp Vault and Conjure SSH management. So those are good examples of where they actually let you manage keys. They provide rotation capabilities as well. They give you one-time access as well. So if somebody just needs access to deploy a certain piece of code during deployment, it's just that key that expires after the first use. So it makes much more harder to kind of hack into those systems or leave keys around quite a bit, and also kind of helps not designing a rocket ship like you see on the top that the cartoon kind of talked about a little bit. So this is, I kind of came across these guidelines, and I think these are really good guidelines in terms of implementing security in your application environment. And they talk about pretty much all the fundamental things, regardless of whether it's DevOps, whether it's anything. It's really good sense that any application development shop should be taking care of. So understanding, what SQL injection is and what the processes are, understanding, security misconfigurations, foundational security hygiene is really important. Hygiene really doesn't come with a piece of code. It is really, again, a practice. It's something that, we clean our house. We clean our house because it's a practice, and we instill that practice. Security hygiene for an organization is, again, something like that. You constantly have to make sure that your high valued assets are secure and you're doing the right things to protect your company. So there are some tooling that I came across. I mean, this is not an endorsement for any one of them, but I would probably encourage you guys to kind of go check out these tools. They all kind of do one thing great and the other thing no. Some have great UIs and great logging techniques, but then the others don't do stuff that you really want them to do. So take a look at, these are open source as well as that's available through these big vendors like IBM and HP and others, but they all have their pros and cons. So overall, recommendation is, one thing that happens with infrastructure as a code is you start treating your end deliverable as an immutable, component. And that immutable component is that once you've validated, once you've figured everything out, that it's clean and great, it goes out and it's published out in the open for consumption. If things have to change, you can't change that one. You can't change that artifact anymore. You have to create a new immutable artifact and then replace the one that you had published. You have to destroy the one that's out there. So that's where the immutable concept kind of comes into play. Again, we talked a lot about integration, security, compliance, testing into your DevOps pipeline. That's important. Scanning is important. Scaling is really important because it can get really busy if you have a pen testing machine and an infosec team that's sitting with development and you're doing a whole bunch of code checks, the application code checks as well as security checks in your code. It could actually amount to a lot of things. But all these recommendations are important in terms of automation, about how users are accessing and so on and so forth. And most importantly, it's also about the culture, having an understanding of how your application delivery is going to change or what you are taking on as an organization is really important. So in closing, all I probably want to say is, security first. It's never an afterthought. I think it's the old adage. We should never stay away from it. And it's again about the culture. It's a lot about the culture. All these policies and frameworks are available. A great way to start is, look at the NIST framework, and those policies can be converted into checklists, and those checklists can be provided to your PMO office for implementation in the code. If that's a really great way to start, if you don't know how to start or where to start. Then, it's also about what we talked about was how to bring security into DevOps. And that's where it's important for the security teams to adapt to this new culture of DevOps as well. So it's not just about DevOps getting more control and they're free, but then security teams need to come back in as well. And the DevOps teams need to understand regulated environments too. They can't relax that, because in our case as well, although we are a very new shop, we're building stuff, but our end consumer is a federal agency, and we know how cruel they are in terms of accepting any piece of software. So ownership is really on all of us to kind of do a good job and test out the tools that are out there. And there is a need for best practices, although we do see a lot more coming out. But using those and then making it applicable to your company and enterprise is really important. All right, so with that, I want to thank you for the time, and I really want to thank you because that thing helped. So any questions? Yes, please.
Yeah. So I saw some of the compliance-minded agencies that you support. How do you get those customers, their security compliance organizations to buy into your DevOps product? They're going to want more satisfied compliance.
So I have to be honest about those companies. That's not where we deploy DevOps. As Merlin, we are actually managing their host and intrusion prevention. So we architected and deployed them. We also manage their large, all their endpoint management systems. Actually, we manage them as well. So we deployed them, we stood them up, but then none of these organizations actually have a DevOps component that goes in with it. The only one that we are actually working with right now is the Homeland Security, and it's in the very early stages. But in that case, we are so early in the game, we are defining the application, so we are defining all the security requirements during the design phase of the application. and we're bringing all those constructs up front on how we want to leverage DevOps, what the PMO office is supposed to do. When we put the tickets together for the roles that people need to have, I mean, we made sure that the tester is part of the development team. A product owner is available during the development phase as well. The security analyst is available during the, so we had headcounts for each of those roles to come in. So I think it kind of starts building that culture up front. So in a greenfield, we were able to do that. Many of these other deployments that we've done, they were already existent, or, so we didn't have much leverage, and we just kind of adopted what they had actually done. Right. Yes.
Will you be posting a version of the file that's not company confidential?
Yes, I have to, yeah. I'm really bad at PowerPoints, although this looks really pretty, but I hate PowerPoints, and most of my stuff is on Confluence. I will actually remove confidential, and I'm going to produce a PDF and then pass it on.
Perfect.
Yeah.
It's very well done, so I'm
Oh.
glad to know that you'll be able to share that.
Thank you. Yeah. Any other questions? Yes.
Yeah. Do you have recommendations for security teams that are inherently separate from the development and operations teams? So by structure of the company, they can't necessarily embed as well as do it. Like, do you have any recommendations for getting towards this sort of model, like when you have those separate teams?
So do you, so the question is like, if the security teams are very far away from the development teams, how do we still bring them together? So the question I have is like, this development team that you talk about, I mean, are they already using agile methodology, and are they already set up that way? Okay. So I think it's important for the stakeholders to have a conversation and make sure that the risk of not doing something is exposed across. I think that getting that awareness is first thing is really important. I always start with because everything is process, but if I don't have a standard, I can't put a process, I can't put a procedure together. So showing how this would be important, even providing requirements that, hey, we need to know what standards to operate against. We need that understanding. I'm pretty sure CISO would be all ears. I mean, they would want to know that, hey, this is something that needs to happen. CIO and CISO, I think they should definitely be very close. And in most organizations, we kind of see they're kind of channeling up to the CEO. So their objectives is really to keep the company safe and operational. Although their functional requirements change, after that point, because one's on security, others on application uptime. So, but they still have the same channel to kind of go up to. So I would say escalate it up and try and get buy-in from leadership. Yeah. Okay. Yes, please.
To build on that, in those sort of very siloed companies and trying to do DevOps, then who's ultimately accountable?
Not me.
That's the problem.
It is really hard. No, it's because it's a culture, because.
Can you repeat the question, please?
Oh, sorry. So the question is, like, piggybacking on this question around silo teams, like, who is the ultimate responsibility on the top? I mean, I always go back to the business owner, right? To me, a business owner is spending the money, and they have an objective in terms of revenue attainment at the end. And if they see that, teams are working in isolation, and I've seen that happen in North Face as well. I've kind of seen that every company, every team is given their own funding, and they go and do stuff on their own. But at the end, the mission ends, and nobody knows whether it was fruitful or not. So getting that, focus from the business owners is really important. Getting an understanding from the development team, owners of the development team, not the developers itself, but the ownership of that whole stack, and getting those people to talk about that this is how we are changing the company, or this is how we are moving forward, because we want to align with these deliverables that the business has. It's always a business conversation in my mind. I mean, most of the time that I'm spending today is really making sure and making the case that I'm in alignment with the sales and the marketing and those teams and the security team. So, we're always delivering a product that sells, So I thank you very much for the time again, and I hope it was useful.